Now we are going to look for the isomerism that a coordination compounds actually exhibit. So we have two kinds of isomerism. As you all are aware of the definitions for the isomerism, that it is the same, compounds have the same molecular formula but different arrangement is there. So it commonly shows two kind of isomerism. One is the structural, means different bonding pattern, and one is the stereoisomerism, that is the difference in the spatial arrangement. That means those atoms, or you can say the members of the compound, are actually show a different kind of spatial arrangement. So first we will start with the structural one, that means they have the same chemical formula but different bonding pattern. So here it is subdivided into many categories. We have linkage isomerism, we have coordination isomerism, we have ionization, and we have the solvate one. Solvent is also called as hydrate isomerism. So just see that what kind of changes do we get to see in these kinds of compounds. So first we will start with the linkage. See, linkage isomerism is shown by those groups or ligand, actually you can say, which can link to the central atom in both the in both ways. That means I am talking about the ambidentate group. That means that have more than one donor site. Like I have a nitro group, it can link to the central atom through N also, and it can link to the central atom by O also. So this kind of groups are actually, though they both are NO2, but the linkage can be through N also, and the linkage can be through O also. So depending upon that, like in case of ambident ligand, we can see the isomerism that is called as the linkage isomerism. As I have an example for you, see, this is pentaamine nitrito N, because it is linked with N, cobalt 3 chloride, and this is pentaamine nitrito, right, pentaamine nitrito cobalt 3 chloride. So what is the difference between two? As they both possess the ambident group, that means here the linkage is by N and here the linkage is by O. So this kind of like the change if you get to see in a molecule, that is called as the linkage isomerism. Second is the coordination one. So what happens in the coordination one? It is actually seen in the complexes like in which we have an ionic complex also, we have a cationic complex also. And what is going to happen in this case? There will be exchange of ligands. There will be exchange of ligands between the cationic and the anionic complex. As you can see here we have CrNH3 6, that means the ligands for the chromium central metal atom is ammonia, 6 ammonias. And for this there is a cobalt and ligands are cyanide. We can write it isomerism by just shuffling of the ligands. As you can see what I have done here, I have just exchanged the ligands. Now cyanide is the ligand for the chromium and NH3 is the ligand for the cobalt. So this kind of thing, if you observe between the cationic and the anionic complex, that is the exchange of ligands. It is particularly a coordination isomerism. Third we have is the ionization isomerism. Here the difference lies between what is going to shuffle in this case is the anion. What kind of anion? The two anions particularly, one is the ionizable and one is the non-ionizable. As you can see that I have this kind of compound. Here it has two anions. Br is the the primary valency, you can say, or you can say it is ionizable anion, and sulfate is non-ionizable. Now what I have done, when I have wrote its isomer, I have just exchanged their anionic. That means the ionizable ion now becomes a ligand and the non-ionizable ligand now becomes the ionizable the group. So this is how, see, this was unionizable and this was ionizable. I just exchanged two. So that is that kind of thing is called as ionization isomerism, in which there is a difference between they differ in the ionizable anion with the anionic ligand. They will both exchange their place. Last one, structural isomerism, is the solvate one. This is also called as hydrate isomerism. It actually differ in the number of the water molecules present in the complex ion. As you can see in this case, how many water molecules are there in the complex ion? 6. As you can see, 6 ligands, 6. Now in this case what I have done, I need to fulfill the coordination number for the cobalt, that is 6. So what I have done, I have just passed took out 4 water, I kept 4 H2O as ligand and I took out 2 H2O outside, and in order to satisfy the coordination number, I just moved 2 Cl from the ionizable anion into the inside complex ion. So this kind of thing, like when you see that there is a difference in the number of water molecules which is present in a complex ion, so that is called as the solvate isomerism. But keep in mind, whenever you are doing these kind of isomerism, when you are just shuffling the groups or you are shuffling the linkage or any kind of thing you are shuffling or you are just looking in the isomerism, coordination number should not be changed, it should remain same. As you can see in all these cases, the examples which I took, I didn't change the coordination number. If the ligands were 6, they were present as 6. If the ligands were 4, they remained at 4. What actually I did, I just shuffled the group, that means I just changed the bonding pattern, but the coordination number remains the same. So don't change the coordination number, right? You can just shuffle the, like in this case we shuffle the atom, like in the ambident group it can join from either side, it can link with N and can link with O. This is what I changed, but I didn't change the number for the NO2. Here the coordination number for the cobalt is 6 and it's same in this case also. And like in this case in the coordination one, here the coordination number for chromium was 6 and for cobalt was also 6. I just changed the ligands, the coordination number remained the same. Even in this case, I just exchange the anion, ionizable anion with the anionic ligand, though the coordination number again remained the same. Similar thing happened in this case, so do not change the coordination number. Don't do that like when you are writing the isomerism, do not change the coordination number. It's very important, because if you change the coordination number, the whole compound, whole question is going to be wrong. So you need to focus on the coordination number. Just try to shuffle the groups. If it is ambident group, if it's water molecule, if it is you can say exchange between anion and the anionic ligand, so just shuffle them up, not the coordination number.